Good evening, my name is Kaumiatat. Today I will be presenting my research on process safety management in semiconductor manufacturing, focusing on how integrating safety, quality, and sustainability can improve operational reliability. Semiconductor manufacturing is one of the most advanced but also high-risk industries. It involves hazardous chemicals, highly automated systems, and tightly interconnected processes. Traditional safety frameworks are often not sufficient because they are designed for more stable environments. This creates a need for more integrated and system-based approach to safety. The aim of this research is to evaluate existing process safety management frameworks and explore how they can be improved. Specifically, this study focuses on integrating safety with quality management, sustainability, and operational reliability to create a more effective system. To achieve this aim, four main objectives were defined. First, to identify key hazards and risks in semiconductor manufacturing. Second, to review existing PSM frameworks. Third, to analyze how quality management principles and sustainability can be integrated. And finally, to propose an improved integrated model. This study uses a mixed methods approach. Primary data was collected through a survey of 30 respondents. This is supported by secondary data from literature. The data was analyzed using descriptive statistics and thematic analysis, allowing both quantitative and qualitative insights. The findings show that risks in semiconductor manufacturing are multidimensional. Chemical hazards account for 40%, followed by human factors at 33.3%, and equipment-related risks at 26.7%. Respondents also strongly agree that risks arise from system interaction with a mean of about 4.2 and rated process complexity very highly at around 4.5. This indicates that risks are not isolated but interconnected and systemic. This aligns with literature. Perez theory explains that accidents arise from interactions rather than single failures. In addition, Leifson highlights that complex systems increase the likelihood of cascading failures, where small issues can propagate across the system. The effectiveness of current PSM frameworks was rated at a mean of 3.3 out of 5, indicating moderate performance. Incident prevention is slightly lower at around 3.2. Most respondents, 16 out of 30, described system-based balance rather than fully proactive. This suggests that while frameworks provide structure, they are still not fully effective in dynamic environments. This aligns with literature, which shows that traditional PSM approaches remain reactive and struggle to manage evolving risks. The findings show strong agreement on the importance of quality management and process safety. Primary data indicates that quality tools are rated highly, with more responses in the range of 4 to 5. These tools support early detection of deviations and improve process stability. However, their effectiveness is limited by the organizational silos and data isolation, meaning they are not fully integrated into safety system. Importantly, there is strong support for integrating quality and safety, with responses predominantly rated 4 and 5. This aligns with literature from Montgomery, which shows that quality tools improve system stability but require integration to achieve their full impact. From a sustainability perspective, the findings show strong awareness of environmental impact with a mean score of 4.4. There is also high concern regarding waste of materials and energy with a mean of 3.8. In addition, respondents show strong agreement on the importance of system-level thinking with a mean of 4.5. However, the sustainability integration into practice remains low at a mean of 2.7. This creates a clear perception implementation gap of approximately 1.7 to 1.8. This shows that sustainability is well understood but not fully implemented. This aligns with literature, which indicates that sustainability depends on integrated system performance rather than isolated efforts. One key finding is the strong importance of integration. 26 out of 30 respondents, or 86.7%, agree that integrating safety, quality, and sustainability is essential. Real-time data and monitoring were also rated highly, mostly between 4 and 5. In addition, all respondents, 30 out of 30, agree that integration will improve safety performance. This indicates a strong consensus towards data-driven, coordinated systems. This aligns with literature from ASIF, which shows that integration improves organizational performance and decision making. The main challenges identified are organizational rather than technical. The biggest barrier is organizational silos, reported by 30% of respondents. This is followed by the cost at 20%, resistance to change, and lack of expertise at around 17% each. Data integration issues account for 10%, while 7% reported no major barriers. These findings show that fragmentation exists across organizational, technical, and capability dimensions. This aligns with literature, which show that functional silos reduce system effectiveness and coordination. To address these challenges, this study proposed an integrated process safety management model. The model includes three interconnected layers. First, the safety management layer, focusing on hazard identification and risk control. Second, the process control and quality layer, using tools like SPC and FMEA for early detection. Third, the sustainability and performance layer, linking safety with an environmental and operational outcomes. These layers are connected through a continuous feedback and real-time data, and enabling proactive and adaptive risk management. This aligns with literature supporting system-based and integrated safety approaches. In conclusion, process safety risks are multidimensional, involving chemical, human, and equipment factors. FSM frameworks show moderate effectiveness with a mean of 3.3, and most systems are balanced rather than fully proactive. Quality management shows strong impact on safety with high rating of 4 to 5, but integration remains limited by organizational silos and lack of integration. Sustainability shows a clear gap between high awareness with environmental impact at 4.4 and low implementation at 2.7. Overall, both empirical findings and literature consistently support the need for integrated system-based and data-driven safety management. This demonstrates that safety, quality, and sustainability are interdependent and must be managed together to improve operational reliability.